So this one is going to cover Unit 2A, working with units. So the unit is a quantity described with the quality measures or counts. Okay, so we use units all the time. If you say 20, you have to kind of clarify it. $20 is very different than, say, 20 cars or 20 textbooks. So the cars or the textbooks would be the unit of which you are talking about. When you're dealing with units, there's two words you really have to pay attention to. Per, as you'll see in miles per hour, feet per second, something like that. That means divide. Or of, which means multiply. So let's do a couple examples. What's the total distance traveled when you run 7 laps around a 400-meter track? So we've got 7 laps. We have 400 meters per lap. So there's our divide. Notice the laps canceled. 7 times 400 is 2,800 meters. Make sure when you are doing these that you put the unit of measurement on there. Okay, they've got to, kind of like before, you've got to tell me what the unit is. If you just tell me 2,800, I don't know if you mean 2,800 meters, 2,800 miles, 2,800 laps. What do you mean? Okay, so make sure that when you do these, you do put the measurement or the unit on the end. For B, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So we've got 2,000 apples. We are going to divide by 40 apples per crate. Notice the apples cancel. 2,000 divided by 40 is 50. And if we divide fractions, we flip it and multiply, so 50 crates. So notice if you divide the unit by itself, it cancels out. If you multiply the unit by itself, you can end up with squares or cubes or something like that. So if you work with area, carpet is measured in square feet, flooring is measured in square feet, volume can be cubic feet or cubic yards or something like that. So there's lots of different measurements that you can use. So identify the units in each measurement. The price I paid for gasoline found by dividing the total cost. Okay. So that would be dollars per gallon. For the second one, area of a circle. I've got pi r squared. Note that pi is a number, 3.14159 ... Goes on forever. So the only thing that is being squared is the radius, which is in centimeters. So our units would be centimeters squared. And then the volume found by measuring an acre by the depth measured in feet. That would be foot acre. It's kind of a weird measurement. Okay, but it's the amount of liquid needed to cover 1 acre of land, 1 foot deep. All right, so what's kind of become the classic example of make sure that you have the right measurements was back in November of 1999. NASA was going to send a probe to study the weather on Mars. It did not make it. Within a half hour, they realized it had hit the top of the atmosphere and burned up. The problem was the thrusters were calculating in pounds of force. The software was using the metric measurement of newtons. They are not the same. So it ended up going 105 miles lower than it was supposed to. It was not supposed to get any closer than 53 miles of the atmosphere. It got within 37 miles and burned up. So even if you are a rocket scientist, if you do not put the correct units down, you're going to get it wrong. So make sure you keep track of your units and how it works. All right, so if you do need to convert from one unit to another, such as miles to kilometers, quarts to cups, okay, we're going to set up an equivalency fraction. And that is a fraction that is the same. So, number 3, I want to convert 102 inches to feet. So we'll get 102 inches, and we're going to convert that to feet. So 1 foot is equal to 12 inches. Now notice that inches was in the numerator for the first one. That means inches is going to be in the denominator for the second one, because I need inches to cancel out. So inches cancel out. I'm only left with feet. And 102 divided by 12 is 8.5 feet. If I want to convert 3,000 seconds into minutes, I've got 3,000 seconds. I'm converting to minutes. So seconds goes in the denominator so that they cancel. And 1 minute equals 60 seconds. So they cancel, and you're left with 50 minutes. For number 5, how many seconds are in a day? So we need to convert day down to seconds. So we write down 1 day. Our first conversion is going to be from day to hours. So we put day in the denominators, hours in the numerators, 24 hours in a day. So days cancel. Then we're going to convert hours to minutes. So we put hours in the denominator, minutes in the numerator, and there are 60 minutes in an hour, so hours cancel. Then we're going to put minutes in the denominator, seconds in the numerator, 60 seconds in a minute. The minutes cancel. So the only unit left that hasn't canceled is seconds. So 1 times 24 times 60 times 60 gives us 86,400 seconds in the day. Don't always assume that just because there's a time sign or a multiplication sign that you multiply. You do not have 240 watts. You have 4 60-watt light bulbs. They do not combine. All right, sometimes we need to do a conversion, and we don't know exactly how the powers work. So, for example, I've got a carpet that's 10 feet by 12 feet. It gives me 120 square feet of carpet. Okay. I don't know what the conversion is from square feet to square yards, because carpet's usually sold in square yards. I do know that 1 foot or 3 feet equals 1 yard. So I'm going to square both sides. So 3 squared is 9. So 9 square feet equals 1 square yard. All right. So we're going to take 120 square feet. We're going to do our conversion ratio. So 1 square yard equals 9 square feet. The square feet cancel. I am left with square yards. And 120 divided by 9 is 13.3 repeating. So I'm going to need 13.5 to 14 square yards to cover the carpet. For number 7, I got a vegetable garden that's 40 feet long, 16 feet wide. I want to fill it 1 foot deep. Call up the landscaping company. They say, hey, we'll sell it to you, but we're going to do cubic yards. So how much do I need? So continuing from number 6, 3 feet is 1 yard. So if I cube it, 27 cubic feet is 1 cubic yard. So I multiply 40 times 16 times 1, and I realize I need 640 cubic feet. So cubic feet to cubic yard conversion is 1 to 27. To cubic feet cancel, and 640 divided by 27 is 23.71 cubic yards. All right, a couple examples of what not to do. So this one gives a canopy at 10 by 10, so 10 feet by 10 feet, and then tells you that it provides 64 square feet of shade. Not quite. The one below it is a 12 by 12 canopy, which they claim offers 81 square feet of shade. Nope, that 12 times 12 would be 144. So here are a bunch of different conversions for stuff in the U.S. Some of them you are very common with. 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, or 5,280 feet. Okay. Some of them are a little bit different. 1 rod is 5.5 yards. 1 fathom is 6 feet. A furlong is 40 rods, or 1/8 of a mile. And then you've got your grains, your ounces, your pounds, your tons, your long tons. For those that cook, you've got tablespoons, teaspoons, cups, fluid ounces, pints, quarts, gallons, the whole works. Okay. So you have a lot of different things. I would not recommend memorizing these, but I would recommend having it close by when you do take the test so you can do the conversions. All right. So the Kentucky Derby, probably the most famous horse race in America. It's 10 furlongs long. How long is the race in miles? So we're going to do 10 furlongs. We're going to convert it to miles. So furlong goes in the denominator, miles goes in the numerator. From the top of the page, we learn that 1/8 of a mile equals 1 furlong. Furlongs canceled. 10 times 1/8 is 1.25 miles. So the Kentucky Derby is 1.25 or 1 1/4 miles. The rest of the world uses the metric system. They use meters for length, kilograms for mass, seconds for time, liters for an abbreviation, and everything is done in sets of 10. So if you want a quick little reference, a meter is about a yard. It's a little bit longer. 2 pounds is about a kilogram, and 1 liter is about a quart. Okay, they're not exactly, but close enough. You can kind of get a reference for them. And then once again, everything is in sets of 10. So here is the conversion. So a decimeter is 1/10 of a meter. A centimeter is 100th of a meter. A millimeter is 1,000th of a meter. It doesn't matter. Okay. I can do a millisecond. That's 1,000th of a second. A milliliter is 1,000th of a liter, and a milligram is 1,000th of a gram. So these are kind of your general. For those that do computers, you probably recognize the kilo, the mega, the giga, and the tera from your bytes. So a kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. A gigabyte is 1,000,000,000 bytes. And a terabyte is 1,000,000,000,000 bytes. Okay, kilometer is 100. That's 1,000 meters. Kilogram is 1,000 grams. Okay. So the prefixes just tell you how many, and then whatever comes after that's the unit. So if I want to convert 2,759 centimeters to meters, there are 100 centimeters in a meter. Centimeters cancel, and I get 0.59 meters. Okay, all you do is, when you're dealing with metric, is all you're doing is moving a decimal. So centa means 2. I'm going to move the decimal 2 places to the left, and we're done. For B, how many nanoseconds are in a microsecond? Well, microsecond is 10 to the negative 6. Nano is 10 to the negative 9. The difference of 3, so 3 zeros, so 1,000 nanoseconds in a microsecond. So here are some US to metric conversions. Okay, 1 inch is about 2.5 centimeters. 1 yard, I said it's close to a meter, it's 0.91 meters. 2.2 pounds to a kilogram. I said a little bit earlier, this is about 2 pounds, so it's a little bit off. 1 quart is 0.946 liters. Okay, so once again, kind of get a rough feel for how they are, so you can kind of keep in your mind about what you need. But this is another little formula sheet that might be good to have for the test. All right, number 10, marathon. Marathon race is 26.2 miles. We want to know how far that is in kilometers. So we got 26.2 miles. Miles, it goes in the denominator. Kilometers are going to the numerator. Okay. We do have a couple options here. Okay. I opted for 1.6093 kilometers is 1 mile. You could go the other way. You could put 1 kilometer in the numerator and then 0.6215 or 14 miles in the denominator. You'd get the same thing. Okay, so it doesn't matter which one you do. But the miles cancel. And 26.2 times 1.6093 tells us that 26.2 miles is 42.2 kilometers. How many square kilometers in a square mile? So 1 mile equals 1.6093 kilometers. Square both sides. And 1 square mile is 2.59 squared kilometers. If you want to catch that, if you want to click on the link and watch the little YouTube video, it's from a cricket game. I have a cricket ball right here. These things are kind of hard, kind of like a baseball if you want a little reference point. And the guy in the little clip catches the ball barehanded and coming off the bat at 141 kilometers per hour. So the question was, how fast was the ball moving when he caught it in miles per hour? So 141 kilometers. Kilometers goes in the denominator. Miles is going to go in the numerator. Just because we'd used the 1.6 kilometers in the previous ones, we're going to flip it. So 1 kilometer in the denominator equals 0.6214 miles. Kilometers cancel, you multiply, and it came off the bat at 87.6 miles per hour. Okay. And if you use the same ratio that we did in 10 and 11, you'd get the same answer. All right, for 13, how much will a person pay for 6 pounds of oranges if the price is $1.57 per pound? So we set up the ratio, times it by 6 pounds, the pounds cancel, and it's going to cost $9.42. Hopefully you've noticed by now that all you are doing with these is multiplying or dividing. So anytime you're doing a conversion like this, okay, you're going to multiply or you're going to divide. That's all we are doing. And sometimes it doesn't quite divide correctly or evenly. So 7 apples for $1, not exactly what you want. All right. The one little exception to the multiplying and dividing rule we just talked about is temperatures. There are 3 major types of temperature measurements. Okay. There's Celsius, Fahrenheit, and Kelvin. So Fahrenheit is what the US uses. So in Fahrenheit, water boils at 32 degrees. water freezes at 32 degrees. It boils at 212 degrees. And then everything is figured out in between. For Celsius, water freezes at 0 and boils at 100. And for Kelvin, Kelvin doesn't go with negatives. So it takes the absolute 0, which is the absolute coldest it can be, makes that 0, and then uses the Celsius measurements of 1 degree Celsius is equal to 1 degree Kelvin. So the absolute coldest we can get is 273.15 degrees below 0 Celsius. So that's how it works. All right. So those are 4 formulas that you probably need. The first one is if I give you a Celsius degree and ask for Fahrenheit, you're going to times it by 1.8, add 32 degrees. If I give you Fahrenheit and ask for Celsius, you're going to take the Fahrenheit, divide by 32, and then divide by 1.8 to get Celsius. If I give you Celsius and ask for Kelvin, you're going to take the Celsius, you're going to add 273.15 degrees. And if I give you the Kelvin and ask for Celsius, you'll subtract the 273.15. So this is a little exception to the conversions of just multiplying and dividing. If you're dealing with temperatures, you will do a little bit of adding and subtracting, but not too much. All right, so the average human body temperature is 98.6 degrees Fahrenheit. I want to know what that is in Celsius and Kelvin. So we're going to put in 98.6 minus 32 divided by 1.8. Now, if you put the green in the calculator without parentheses, you will get it wrong. And there's no caveat to that. If you forget the parentheses and you plug the green into the calculator, you will get it wrong. In this case, you would end up with something around 81 degrees. Okay. 81 degrees is not the answer. So if you were, once again, to plug the green into the calculator, just like it is, and hit enter, it would tell you 81 degrees. And then My Math Lab and I would tell you that is incorrect. You have to put parentheses around the numerator. So parentheses, 98.6 minus 32, close parentheses, 1.8 would give you 37 degrees Celsius. So 98.6 degrees Fahrenheit, 37 degrees Celsius are the same. All right, to get it in Kelvin, we're going to take 37 degrees because that is our Celsius value. We're going to add $273.15 or not dollars, 273.15, and the average human body temperature in Kelvin is 310.15 degrees Kelvin. Once again, when you are doing these, make sure you tell me what unit of measurement you have, because Fahrenheit, Celsius, and Kelvin are very different measurements. So make sure you tell me if it's degrees Fahrenheit, if it's degrees Celsius, or Kelvin. So F for Fahrenheit, C for Celsius, and K for Kelvin. All right. So the Australian Open goes on in Australia in January. It is summer down there, and Australia is a desert for the most part. Melbourne especially. So with this one, temperatures hit 42 degrees. Temperatures on the court hit 69 degrees, and the players are feeling a little bit miserable. Okay. So if we are here in the States and we said, oh, it's 69 degrees, I'm going to go play tennis, we would think that is a great temperature. However, that would be 69 degrees Fahrenheit, The Aussies use Celsius. So how miserable is it for them? So we're going to convert. We'll do 42 degrees. This is the outside temperature. So 1.8 times 42 plus 32 tells us that outside the quartz, it is 107.6 degrees Fahrenheit. That is pretty hot. I would not want to be playing tennis at that temperature. However, when you're in the court and it's closed and there's no breeze and you've got people around, it got up to 69 degrees. So if we plug that in, we get 1.8 times 69 plus 32 degrees. They are playing in a whopping 156.2 degrees Fahrenheit. That is probably why they look like that. That would be miserable. All right. The other thing that we can change is currency. So February 2016, I know this is old, but this is what's on your homework, so we'll go with it. And currencies will change every single day. In fact, they'll change within the minute of every single day. So these are very different from what they are now, but there's going to be some kind of ratio from different currencies to different currencies. Okay, so in this case, we've got the British pound, the Canadian dollar, the European euro, Japanese yen, and the Mexican peso. Okay. So this one is how many dollars you would get per foreign unit of measurement. So if you had 1 British pound, you would get $1.62. If you have a Canadian dollar, you would get $1 and maybe a penny. The next one is how much foreign you would get per dollar. So if I had $1 and I went to Europe, I would get 76 euros. If I went to Japan, I would get 83 to 84 yen. And if I went to Mexico, I would get 12.73 pesos. And once again, they'll change all the time. So just go with whatever is on the table for the test and the homework. So we go to a French department store. We want to buy a pair of jeans. It is 45 euros. What is the price in US dollars? So we got 45 euros. Well, 1 US dollar is 0.7576 euros. The euros canceled. And we are paying $56.40 for the pair of jeans. If we go down to Mexico and we have $100 and we want to convert those to pesos, how many pesos would we get? So $100, so 12.73 pesos is equal to $1. The dollars cancel, and you would have 1,273 pesos. And once again, if you went with the other ratio, you would get the same answer. Okay, so it doesn't matter which one of the two columns you use. Okay, you're going to get the same answer. All right. For number 19, we got a gas station in Canada that is selling gas for $1.34 per liter of Canadian dollars. What is the price in US dollars per gallon? So we've got two conversions here. We need to convert liters to gallon, and that's what the first one does. So we went back a couple pages and remembered that there are 3.785 liters in a gallon. So we have our liters to gallon conversion. It's liters cancel. And if we jump up to the table on this page, 1 US dollar equals 0.995 Canadian dollars. So the Canadian dollars cancel. We multiply and divide, and you are paying $5.10 per US dollars per gallon. And make sure you keep track of all this, because you never know if you will ever be asked if a euro is worth $1.50. What is 5 euros worth? I'll go ahead and leave you guys to figure that out.